Good morning, my name is Cervellieri. I'm full professor of the Department of Information Engineering of Polytechnic University of America. My research article is titled Analysis of Stability of Gravitational Waves with the use of the Lyapunov algorithm for nonlinear systems with free-form neural network method. The abstract of my research article is this. Accurate stability estimation for Lyapunov is a critical goal in pursuing the safe behavior of dynamic systems. In this article, the neural network feed-forward algorithm with Lyapunov functions was combined to calculate the analysis of the gravitational waves for nonlinear systems. This method uses the strength-both algorithm to guarantee the stability of a system even in presence of uncertainties in the parameters or external disorders. In addition, the algorithm utilized was created using Mata 2023 software and proposes a feed-forward neural network method to predict the dynamic systems process. The validity of the algorithm was determined by the effects of stability of Lyapunov by comparing the machine learning methods and by simulating the comparing the results of the training, validation, and test curves, algorithm what test. Finally, the mean square error and the evaluation of root square plots in training, test, and validation stages during the training for the algorithm demonstrate that the simulation conducted this paper correctly represents the state of safe behavior of dynamic systems and confirm the results and the validity of the feed-forward neural network suggested. In this article, the author Cervellieri adopted a combined approach made up of the following phases. In the first phase, the author dealt with the forecast of the stability of the Lyapunov function. The neural networks have been trained in this article to provide the functions of the Lyapunov on nonlinear systems. This entails the use of a network to approximate the Lyapunov function and its derivatives and has been used to evaluate stability. The second phase concerns the design of a calculated gravitational waves. The Lyapunov function has been used to design below the guaranteed stability even in present or uncertainties that derives in the present or nonlinear systems. The third phase concerns the evaluation and analysis of the results. In particular, the author evaluated a combined method that allows a detailed evaluation of the system stability by analyzing the expected Lyapunov function and the stability laws designed by the algorithm that are created using an artificial intelligence algorithm without using the mathematical equations that derives. It cannot be evaluated using classical laws of quantum mechanics, but only through an few neural network algorithm, specifically chosen to model the nonlinear system. I define the term nonlinear system as referring only to those regions of the universe represented by those particular stability laws, especially calculated by the few neural network algorithms defined in conjunction with the stability analysis of gravitational waves. The FIBO neural network is trained using system input leaking data to learn the dynamic of the system itself. The author defined a Lyapunov function for the nonlinear system where X represents the state of the system as it is possible to see in figure 1 in the diagram of Lyapunov function. The Lyapunov function must be positive, defined, and its temporal derivative must be negative, defined to ensure stability of the gravitational waves. The neural network architecture comprises two hidden layers with 15 neurons and one output layer. The trigger function is characterized by ReLU function and linear activation. Hidden layers use the rectified linear unique function. The output layer has a linear activation function. When it comes to splitting data, the data is automatically split into. The splits of the data are done and provided as training 80%, validation 10%, and test 10%. Set. The operation of a fewer neural network algorithm is composed of several sequential phases. In the initial phase of a forward path, the input data is transmitted through the network. The output of the impulse waves is calculated, bias is detected, and the activation function is applied. The output of the final layer is associated with the target values. The second phase related to the calculation of the error, in which the difference between the expected output and the real one is terminal. The third phase concerns the establishment of the weights. The weights are revised using the BR optimization algorithm. The fourth phase is the process of iteration. The author repeated this phase for a number of epochs required or until a converse criterion is established. The Firewall neural network model was developed by MATLAB 2023. I chose this algorithm, believing it was the only one appropriate for precisely defining a deflection detected over the 20 years time period considered 2005-2025 that evolves in a manner undetectable by standard mathematical algorithm. Since this deflection is caused by an energetic instability and it cannot be evaluated using the classical laws of the quantum mechanics, but only through a firewall neural network algorithm, specifically chosen to model the nonlinear system. I define the term nonlinear system as referring one to those regions of the universe represented by those particular stability laws precisely calculated by the firewall neural network algorithms, defined in conjunction with the stability analysis of gravitational waves. In figure 2, I reported the diagram of the algorithm of a few-fold neural network. And in figure 5, I reported a prediction of Lyapunov state reported in a precise manner with a mathematical equation calculated as the secret formula with the representation of actual Lyapunov state and predicted Lyapunov state that are reported in this research article. The prediction of a Lyapunov function combined robust controls with the use of thin-form neural network algorithm to fully evaluate in a precise and exactly manner with a mathematical equation with the physical equation without the use of a mathematical algorithm and a quantistic mathematics and mechanics, quantistic mechanics, to fully evaluate a predictive method that analyzes the state of stability or controls for stability of gravitational waves or for nonlinear systems. However, evaluating stability for nonlinear systems is often difficult due to numerous factors such as high complexity computational and measurements cost and density and energy density. For these reasons, and energy waves, energy waves. For these reasons, in this article, simulations has been conducted based on a few new forward feed neural network algorithm. This article predicts the Lyapunov functions combined stability laws of using artificial intelligence algorithm to predict the case in which the stability of Lyapunov became instable and makes so the expansion of the universe. With the use of Lyapunov algorithm, I have defined in exactly manner, and without the use of physics, only physics, without quantistic mechanics, the state of stability for gravitational waves, and predict in exactly manner the exactly point of deflection that makes it possible the expansion of the universe and passing from a stability state to a instability state for a nonlinear system for the universe. So, in a particular zone that I have defined in an exactly manner. The robustness of a proposed algorithm against the phenomenon of high complexity computation was evaluated for controls for nonlinear systems. The results were verified by comparison with scientific literature, obtaining lower value of MSE, mean square error, and higher value of root square error. Excellent results were obtained from a study that provided a correct prediction of the stability of the Lyapunov function. In conclusion, the author, with the use of this new predictive method, combined approach for the design robust control by providing for the stability of the Lyapunov function will fill forward neural network method without the use of a mathematical equation, but only with the classic equation and classic theorem, but only with the use of feed-forward neural network that I create in an exactly manner to predict in a precise manner the stability law for the expansion of the universe. And as of future research, adequate information regarding balancing performance, cost, and assumptive prediction. In the future, the author aims to create a new application of this feed-forward neural network method to address in greater detail the equation or state of stability of gravitational waves to define the expansion of the universe, as I have said before, for the nonlinear, for the case that I define non-linear system, for the situation that I already described. Thank you for your attention. I'm at your disposal for any comments or as well any questions.